Hello, and welcome to CENAMEP AIP. In the era of digital transformation, technology has revolutionized the way we live, work, and communicate. From artificial intelligence to the Internet of Things, technology is rapidly transforming our world. But it's not just about technology. True digital transformation involves a new way of thinking and doing business. It's an opportunity to change how we interact with our customers, improve the efficiency of our operations, and innovate in all areas of our companies. In this video tour, we will see how the intervention by the project automation of equipment data capture through image recognition techniques takes place in 3 laboratories of our NMI. As a first stop, we have the Secondary Time and Frequency Laboratory, the S1. Here was born the idea of developing a platform for the automation of data capture using image recognition techniques, specifically for handheld tachometers. Currently, the project wants to cover different calibration services of the NMI, involving devices without communication interface, through an application made with free software, in this case using the Python programming language, with a friendly graphical interface for the metrologist based on the Qt library, which allows saving data in a SQL database, MySQL or SQLite, and control by GPIB of the standard equipment that allow it. Here we can see the user interface, on the right the control and configuration panel, on the left the main view and the windows with the cropped and processed image to be read by the Tesseract OCR, character recognition engine. For the capture of the images, we maintain a controlled environment. We're using the position of the equipment in a favorable angle of incidence with respect to the ceiling lamps, and with dedicated lighting, the best results are obtained. The camera is professional with 1.3 megapixels and up to 60 frames per second. The E4 Multifunction Laboratory is the second laboratory where we are working on automated reading, for which the software was modified, including the parameterization of equipment and characteristics according to different devices under test, adding tables in the database and including more options in the configuration tools. We are also working on improvements for the use of low-cost cameras. In this case, a webcam was used. Although it maintains a lower resolution of only 720 pixels, the distance to the device under test is smaller, compensating for this deficiency. Even though this scenario is more susceptible to disturbances and noise, it is necessary to control it in order to make it more accessible to all laboratories. The need to train new recognition models with characters found in other devices is being studied. Here we see how the program does not recognize all characters and is not fast enough to respond to LCD display changes. The software has an evaluation module, intended to verify what is captured before being saved in the database, filtering data created as hallucinations by the OCR engine. At this stage, we are capturing data to determine the best way to evaluate handheld multimeters. H0 and T1, relative humidity and temperature secondary laboratories, are among the most incipient interventions that have been carried out within the context of the automation project. Here the particular use of the tool would be associated with reading the equipment under test, which do not maintain the data storage, or with proprietary software that does not allow the reading of the same and are in calibration within the climatic chamber with humidity and temperature control. The resolution of the webcam and the distance to the device is an insurmountable challenge. However, it can be seen that the thresholding algorithms by Otsu's method make the tool sufficiently robust against reflections from the window glass. Note the reflections of the moving metrologist and the little movement in the processed image. If we go back to the professional camera, the higher resolution and its better handling of the dynamic range of illumination, in addition to the variable lens that allows zooming and fine focusing, provides a video flow with more information to the program, allowing it to obtain better results in the recognition of characters. This is the point where the cost-benefit of a better camera must be analyzed. As trivia, the device we see is another SIM project, the thermohydrobarometer while performing validation tests. Working with Tesseract OCR using different models trained with different character types allows the tool to be adaptable to a wide range of font types of 7-segment or continuous characters. Plus, the tool allows configuring the contrast inversion of the images for the case of illuminated displays such as this OLED. In this laboratories, the adaptation of the tool is still in the first steps. It must be determined if the small contribution of temperature that the video camera does not affect the climatic camera, and if moving away this can reduce the affectation without being hindered by reflections on the glass. We are looking for continuous improvement and the implementation of developments that support the metrologist. Thank you for joining us for this short visit on the digital transformation work being done.